Okay, so again, here is cosine, and this is an angle, we'll call it A, and this is an angle called B. So it's really cosine of A plus B, because these are inverses, output of inverses angles. So really these two are just angles. It's just that now, in terms, as opposed to having numbers, we have variables. So therefore, angle A, since we're assuming U is positive, though it doesn't really say in the directions, we'll assume it's positive. So this is U over 1, so it's adjacent over hypotenuse. Pythagorean theorem tells me 1 minus U squared. So here's my A triangle. And my B triangle is going to be V over 1, or opposite over hypotenuse, so V over 1. So this is 1 minus V squared using Pythagorean, and that's B. And the cosine of A plus B is the cosine of A cosine of B minus the sine of A sine of B. Well, cosine of A is U. The cosine of B is the square root of 1 minus V squared minus the sine of A, which is 1 minus U squared. The sine of B is V. So my answer is not very attractive, but it's U times 1 minus V squared minus V times the square root of 1 minus U squared. Here's a similar scenario, but instead of U's and V's, we just have one variable, X. So I'll let this one be A and this one be B. We're still doing cosine of A plus B. So my first quadrant angle is going to be X over 1, so it's adjacent over opposite since it's cotan. So X1, so this will be 1 plus X squared. That's A. And then B is going to be adjacent over hypotenuse, so X and 1 minus X squared. So this is the cosine of A, cosine of B, minus the sine of A, sine of B. So the cosine of A is X over the square root of 1 plus X squared. Cosine of B is X minus the sine of A, which is 1 over 1 plus X, square root of 1 plus X squared, times the sine of B, which is the square root of 1 minus X squared. So this is over 1 and this is over 1, so I get X squared minus the square root of 1 minus X squared all over the square root of 1 plus X squared. Not the most attractive answer.